Okay, this is graphs and transformations of logarithmic functions. So a logarithmic function is the inverse of an exponential function. Steps for graphing a logarithmic function. First, write it in exponential form. Next, find the inverse. Then graph the exponential. Switch the x's and y's and graph the logarithm. They should be reflections of each other over the line y equals x. So if we're going to graph y equals log base 2 of x, remember that we're changing it to 2 to the y equals x. Okay, so that's your exponential. Then we're going to switch out the x and the y. So it's 2 to the x equals y. And that's your exponential function. That's the one that we would graph first. So if you want to make a table, you could go x, y. You could go -2, -1, 0, 1, 2, like that. And so if x is -2, then y is negative, or I'm sorry, not negative, but is positive 1/4. If x is -1, y is 1/2. If x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 4. So we're going to start out by graphing that. So the easiest, I'm going to start at 0, 1. So 0, 1, that's an easy one right there. Okay, then 1, 2 up here, and 2, 4 up here. Let's see, 2, yeah, right. Okay, and then we know that over here it gets closer and closer and closer to 0. So starting at 1/2 and 1/4, and it's really hard to, do anything like that. But it doesn't touch 0. Just remember that it gets closer and closer and closer to 0. So now, when it talks about it being the reflection over the line y equals x, so the line y equals x just splits the coordinate plane in half diagonally, and I'm kind of missing all the points there, but maybe I need to get my stylus. That's probably a good idea. So it's just going through all of these little crosshairs. So all the x's and the y's are the same. Let me erase this one up here because I didn't do such a good job. So it just goes through all of those little crosshairs. So that's the line that we're reflecting over. And remember, for inverse, you're just, this one's really the one that we want. So we're just trading out x and y. So we're just going to make these be the y's and these be the x's. Okay, so let's look at how that would work. If I got, let's go down here to 1, 0. So if x is 1, y is 0. Okay, if x is 2, y is 1. If x is 4, y is 2, like that. Okay, and then over here, it's going to just get closer and closer and closer to the y-axis. The curves don't look so great. But you see how if I folded that, if that were a piece of paper and I folded it along that green line, that y equals x, then the orange graph and the red graph would land on top of each other. So now remember that an asymptote is a line that the graph gets closer and closer and closer to, but never touches. So here, the asymptote of this one, the line that this gets closer and closer and closer to, is the y-axis. Well, the equation of the y-axis is x equals 0. Okay, the domain, that's all of the things that x can be. So the domain is always going to be, you know, x is greater than whatever the asymptote is, or less than if it's an inverse, or I'm sorry, if it's flipped, if it's reflected. And then the range is all real numbers. So because it goes as far top to bottom, you know, it's going to keep going. So that's what that looks like. All right, let's go to the next example. Okay, so same thing here. Log base 3 of x. So let's try this. Now you pause it and try this yourself. But I'm going to go ahead and do it, and then you can look at it when you can, or or if you get stuck, look at it when you get stuck, or look at it however you want to, however you need to do it. So remember that f of x is just y. So y equals log base 3 of x. So if we want to write this as an exponential, this is 3 to the y equals x. Okay, so to start out, we're going to graph the inverse. The inverse is just trading the x and the y. So that would be 3 to the x equals y. And then I'm going to do my table this way this time. So x, y, and then we'll just go -2, -1, 0, 1, 2. And then if we plug these in, 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. Anything to the 0 is 1. And then 3 to the first is 3. 3 squared is 9. Okay, so we can plot our points. I'm going to start with 0, 1. That's the easiest. And then 1, 3. 3 right there. And then, you know what? I might have messed up that last one. I might have gone up too high. I have to look back. Anyway, and then 2, 9. It's way up there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right up there. Okay, and then over here we just get, it's just an asymptote. It just gets closer, closer, and closer. Like that. It doesn't have to be exact. Okay, the point is, now we're just gonna, for the logarithm, you know, we're just gonna reverse these. Okay, so the inverse is just reversing those. So we're gonna take, you know, so if x is 1, y is 0. X is 3, y is 1. If x is 9, 3, 4, 5, 6, 7, 8, 9, y is 2. And then it gets closer, closer, closer to the y-axis, which is x equals 0. So the asymptote, x equals 0. Domain, x is greater than 0. Range is all real numbers. Okay. Let's see what's next. All right, so this shows us the parent graphs for logarithmic functions. So I'm not going to spend time going over this. You can pause it. You can read through that. You see that if you have, let's see, if b is less than 1. So let's look at that part. Okay, so if you got b less than 1, between 0 and 1, then it goes, you know, it's your exponential decay. So, you know, everything gets reversed. So that's something that we'll pay attention to when we come across a problem like that. Okay. All right, so now if we want to find out which one of these functions matches the graph, we're going to look at what, you know, what is, let's see, hold on a second. Okay, let me get my pointer. Okay, so we're going to look at what these points are. Okay, so right here, you know, at 1, it's always going to be 0. So at 1, it's going to be 0. Okay, but now the big thing to do is to see where it's crossing the next little point. So like we're looking at where it's going to cross 1, if that makes sense. So I'm saying what to the first power. So if I look here, I go up here to 1 and I go across, I see that it's at 3. It's split up into 2, 4, 6, 8. So they're halfway in between, there's 3. Okay, so that's 3. So when y is 1, x is 3, so that tells me that this is log base 3. So you're going to look at that. If it was at 1, if it hit at 2, then it would be log base 2. Okay, so again, we're going to look at this one. So like I said, at 0, it's going to hit 1. But now let's look at where is it hitting? What is x when y is 1? So where y is 1, x is 2. So that's where it hits right there. So that's log base 2. So that answer to that one is A. Okay. So here, the general form is y equals A times log base B of x minus h plus k. So I'm going to start, they have A listed last, but I'm going to start with A. A is going to tell you whether or not it's reflected. So this one, it's reflected if A is negative. Reflected if A is negative. Okay, and then H is in the parentheses with X. So H is going to move you left and right. Because X axis goes left to right. And then K is out here, not hanging with X. So K tells us whether we're going to go up or down. Okay. All right, so we're going to describe these transformations of these logarithms. We just look. Now you pause and write down what you think, and then you can, unpause and see if you were right. So here, this -4, remember, X is a rebel. It's -4. It's like, nope, I'm not going to go to the negative direction. I'm going the other way. So this tells me we're going right 4. And then this one out here, K behaves. So it's going to go up 5. Okay. This one, this negative, says we're going to reflect over the x-axis, or over, anyway, we're reflecting. Okay, so there's nothing in here with x, so it doesn't move left and right. And then -7 goes down 7. Okay, this one, we go left 9 and down 11. This one reflects because of the negative, and then we go right 6 and down 1. Okay. This one, let's see, I gotta pause for a second. Okay, so this one is exponential, and we want to see if it's exponential, it has a horizontal asymptote. Okay, here the asymptote is the line y equals -4. The domain for this guy is all real numbers. And then the range is that it has to be y greater than, not greater than or equal to, just greater than -4. And then this one is logarithmic. And so, of course, you can tell it says logarithmic or exponential. Well, that right there would give away that that's logarithmic. And it has a vertical asymptote. The asymptote then, if it's vertical, is going to be x equals. So here, x equals -8. The domain has got to be x is greater than -8. And then the range is all real numbers. Next, this one is, oh, that's hard to tell, but it shows there's a log there, right? So it's a log, so it has to be logarithmic. And if it's logarithmic, that means it's got a vertical asymptote. And the asymptote is over here at -5. So the asymptote itself is x equals -5. And then the domain, and you can see up there, that +5 means it moved to the left 5. And then the domain is x has got to be greater than -5. The range is all real numbers. And that was the last one of those. I took pictures of your assignments too. So let me pull that up quick. And we can take a look at those questions. Let's see. Yeah. Okay. Now, I want you to try these, but I'm going to put them on here so you can check them. You can go back and look and see how it goes. Okay, so this one, you see, so pause the recording when you start doing your work. Pause the recording and do this on your own, but then you can look and see if you did it right. Anyway, that negative tells us that it's reflected over the x-axis. So it's going to be either this one or this one. And then that inside the x with the 3 means it goes to the left 3. So it's that one, that very first one. Okay. This one, not reflected. Doesn't say it's reflected, but this one means it goes to the left 5. So there's a left 5. Well, that's the only one that has left 5. Left 5 down 6. So this is your baby right there. Okay, this one. Let's see. Yeah. Okay, so we're going to have to see where, to see what base it is, we're going to see where, where y is 1, what is x? And x is 4 right there. So that tells us that it's y equals log base 4 of x. Okay. Okay, and for this one, the features, this is an exponential. The asymptote would be down here at, so it's exponential. Asymptote is down here at y equals -6. The domain is all real numbers, and I probably messed up range there, but range has got to be y is greater than -6. Didn't mess it up. I just lost it. It's there. Go away. Yeah, range. Range is y is greater than -6. Okay. This one, type of function, it tells you log. Ha ha ha, log. Okay, so it's a log. And logs have asymptotes that are vertical. So this is a vertical asymptote of x equals -5. And then the domain would be then x is greater than -5, and the range is all real numbers. And then here, logarithmic, obviously, since that's what it gives you in the equation up there. So it's log asymptote x equals 2. domain x is greater than 2, range all real numbers. And I have to pause for just a second. Sorry about that. And here we go. Let's see. So let's erase all this and go to the next one. Okay, so match the following logarithmic functions to the correct transformation description. So here, this plus 5 is not hanging with x, so that means it went up 5. Okay, this minus 5 is hanging with x, and remember that that one is not cooperative. It's not going to go negative, it's going to go the other direction, so it went to the right 5. This one went to the left 5. This one got reflected. This one went down 5. Okay. I got the same thing. I think I took a picture twice. Okay, so this one we got. Describe the transformation of the following logarithmic function. We've got it reflected, so we know it's either going to be this one or this one. And then that plus 6 means it went up 6, so it's that last one. And then here, we want to know which one best matches it. So we're going to look right here where y equals 1. We're going to go across and see where does it hit. What is x where it hits? And x is 3. So that means it's log base 3. So that's your winner, winner, chicken dinner right there. Okay. Here we go. Logarithm. It's the minus 2 is inside there with the x. That means it's going to be going left or right. And since it doesn't like to mind when it's with x, that means it went the other direction. It went to the right. Okay. Here we got this one going down 4. These don't you love that all these transformations are just the same? They're just, you know, a different function, but the transformations all behave the same way, the same idea. Makes things a little bit less confusing, I think. So, okay, this one, type of function. Well, it doesn't say log up there. Look at that. That's one way to tell. It doesn't say log, so it must be an exponential. The asymptote is up here at, remember, if it's going horizontal, that's a y equals. So that's y equals 2. The domain would be all real numbers. And then the range is going to be y is less than 2. Because it got reflected, it went down instead of up. Okay. And that looks like that's the last one. So I hope this helps, and I will see you next time.